So we have a container, and that container has a little wall in between and a little bit of a hole in between, so there are actually two compartments in this container. Okay, we have 4 items. We'll just call them 1, 2, 3, and 4. The question is, how many different ways are there to arrange those 4 items in this container? So the one pot. Okay, so how many different ways are there to arrange it where all 4 items are on one side? Well, basically 1, 2, 3, and 4, right? There's only one way. So we'll just call this arrangement 1. Okay, all on one side. There's one way. Okay, now how many different ways are there to arrange it so that we have one thing on one side and 3 on the other? So 1 on one side, 3 on the other. Well, fundamentally, we can do 1, 2, 3, 4. We can do 1, 2, 4, 3. We can do 1, 3, 4, 2. And we can do 2, 3, 4, 1. So we'll call this arrangement 2. And we have 4 ways. Well, now, how about 2 on one side, 2 on the other? 1, 2, 3, 4, 5, 6. So we can have 1, 2, 3, 4. We can have 1, 3, 2, 4. We can have 1, 4, 3, 2. We can have 2, 3, 1, 4, 3, 4, 1, 2, 2, 4, 1, 3. Interesting. So this is, oops. Now, I don't want you to worry so much about what it is that we're doing here. The idea that I want you to take home is now I want you to think about this in terms of like, let's say I had this container, this glass container, and in between I had this wall with a little bit of a stopcock, and I put a whole bunch of gas. I put 4 particles of gas in one side of the container. Well, okay, if I open up the stopcock, all right, if I just open this up, what's going to happen? Well, you know from your experience that the gas is going to distribute itself evenly. Well, the reason it does that is the following. If all of the gas were to just stay on one side, there's only one way for that gas to be there. Basically, that's one arrangement. All the gas molecules have to be here. If one particle of the gas were to go to the other side, well, there are 4 different arrangements that it can have. So probabilistically speaking, it's more likely that the system is going to end up here because it has more states, more individual states available to it to actually satisfy, 1 on one side, 3 on the other. Well, now, but how about 2 gas particles on one side and 2 gas particles on the other side, which is what your intuition tells you as far as how a gas distributes itself when you open up, a container and allow it to sort of move over here. So now we have 1, 2, 3, 4, 5, 6. Now there are 6 ways. Well, imagine if you had 1 mole of gas, 6.02 times 10 to the 23rd particles. Well, there's only one way for all of those particles to arrange themselves in one container. However, you can just imagine with that many particles how many ways there are to arrange themselves to distribute themselves evenly, half of them on the left, half of them on the right, with the gas moving back and forth in and out. So because there are billions and billions of ways that that's possible, the probability of finding it in this configuration is virtually nil. It's not going to happen. You're never going to find all the gas in one container. It's statistically impossible. But it's statistically probable that it's going to be in one of these arrangements. In each case, you have half of them on one side, half on the other. But because there are so many possibilities for half and half, the probability that it'll be in one of these states outweighs the other probabilities. That's why a gas distributes itself evenly when you open a stopcock and allow it to escape into the other end of the container. It isn't because of pressure or other things like that, or a vacuum. No, it's because of statistics. It's a probability. It's about entropy. This is a highly ordered system. It has a very low entropy. This is a highly disordered system. It has a high entropy. The system tends toward the series of states that have a higher entropy. That's why it goes this way naturally. It will move in this direction. If you take a gas and put it in a container that has a separation with a little hole in it, the gas will not all of a sudden go to one end of the container and all collect on the left or on the right. It won't happen spontaneously because the entropy going from here to here is going to decrease. In a spontaneous process, entropy always increases. So therefore, from here to here, entropy definitely increases. Therefore, this will happen spontaneously. I don't have to do anything. In fact, all I do is open a stopcock and the gas will rush out and distribute itself evenly. Again, it doesn't happen for physical reasons. It happens because the underlying probabilities make it so. It's because the entropy, it's that property that drives certain systems forward. In fact, the entropy is the only thing that drives all systems spontaneously forward. Absolutely everything. And to this day, we have not found one single exception to any of the laws of thermodynamics. And it's pretty extraordinary. It's been about 150, 160 years that this is the case, and we have not found any exceptions. If you remember the early part of the 20th century, classical mechanics was supplanted by relativity and quantum mechanics, but thermodynamics has not changed in 150 years. It's still just as valid. Now, granted, we sort of used quantum mechanics to get a deeper, atomic molecular view of thermodynamics, but all of the original, ideas, the first law and the second law, they're still valid. So this is what's going on with entropy. I hope that helps a little bit. So, final words here. Because there are more ways available for arrangement 3. For arrangement 3, you are more likely to find the system in arrangement 3. That's it. That's all that's going on. Like we said, there are a whole bunch of ways that a mole of gas particles can distribute themselves in two containers. But there's only one way for a mole of particles to be on one side of a container. Because you have a multitude, billions and billions of ways for it to be distributed evenly, you're going to find the system in that arrangement. That's why we see, the behavior that we see. All processes, all spontaneous processes, display an increase in entropy. If you see something happen naturally, you can guarantee that the entropy, that the change in entropy of that system in going from state 1 to state 2 has increased. It's greater than 0. That's the whole idea. I cannot even begin to tell you how profound and how deep this is, this notion of entropy. It is truly extraordinary. And for me, after all these years, I'm still fascinated by it. And there's still so much that I just Well, anyway, it's amazing. Okay, so couple more things. If you start at arrangement 1, you will spontaneously tend toward arrangement 3, because arrangement 3 is more chaotic. Arrangement 1 is highly ordered. Arrangement 3 is more disordered. There's more movement. There's more freedom of movement with the atoms. Particles can be here and there. There's just more things available to it. Okay. If you start at state 3, if you start at arrangement 3, the system will not spontaneously tend to arrangement 1, because there's going to be a decrease in entropy. It's not going to happen. It's not going to happen, ever. My final advice regarding thermodynamics. Okay, you know what? I'm not going to write this down. I think that's... my advice with thermodynamics is don't rack your mind over trying to understand this conceptually. There's a very, very famous saying with regard to thermodynamics. A very famous scientist in the early part of the century said, nobody really understands thermodynamics. We just get used to it. There's a lot to be said for that, and in a lot of ways that's exactly true. It's true for a lot of things. There are a lot of things that we may not completely understand, but we get used to them, and we can work with them, and we can use them, and we can do practical things with them. So again, don't lose any sleep if you don't necessarily understand. If you were able to follow what it is that I've discussed in today's lesson, and if at least made sense to you, if the arguments were plausible, that's it. You're in a good place. You're ahead of the curve. That's all it needs to be. So don't worry too much about it. Okay, thank you for joining us here at Educator.com. We'll see you next time for a further discussion of spontaneity, entropy, and free energy. Take care. Bye-bye.